Hey physics friends, Mr. Collier here. I've got two sample momentum problems for you today. Our first is a straightforward, let's use the equation. We have a student with a mass of 50 kilograms and they have a momentum of 100 kilogram meters per second. How fast must they be traveling? Well, momentum, which is this P looking symbol, it's a Greek letter though, is equal to mass times velocity. We know the mass, we know the momentum, we're solving for velocity. So I'm just going to rearrange that. Velocity equals the momentum over the mass. So we've got 100 kilogram meters per second over 50 kilograms. Notice that the kilograms cancel out and we're left with meters per second, which is a unit for speed. So that makes sense. And 100 over 50 is 2 meters per second. So that's the first sample problem. In our next one, we're going to talk about something a little different. We're going to talk about change in momentum. So anytime we're talking about change, we're talking about final minus initial. So we just need to figure out the before and after momentum and subtract them. So here we have a 1 kilogram ball that's going 2 meters per second. That's the initial conditions. It bounces off a wall and it's going 1 meter per second afterward. And an important thing to remember is that's going to be in the opposite direction. And we need to indicate the opposite with an opposite sign, positive versus negative, because momentum is a vector. So it's very important that we have those signs. So let's do the final and the initial. So the final momentum is going to be the mass, which is 1 kilogram. That won't change because of the bounce, times the final velocity. Now it's going 1 meter per second, but it's going in the opposite direction. So I'm going to indicate that with a negative 1 meter per second. And I'm going to subtract from that, back over here, I'm just going to call this change in momentum and go ahead and do the final minus the initial. The initial then would be at the beginning, so it's a 1 kilogram ball going 2 meters per second, and we're going to call that positive. And so when we subtract those, we get negative 1 minus 2, right? Negative 1 minus 2. So the total change in momentum is negative 3. It has changed by 3 kilogram meters per second from positive 2 to negative 1. And another way to think about that is like, if you were on a number line, right, and here's 0, it was at 2 and it went to negative 1. That is a change, right, of 3. All right, so that's that sample problem. Let me know if you have any questions.